Welcome to JFix and a new video, and I've got a laptop motherboard to have a look at, so let me take you to my bench and show you what I've got. Okay, so here we have it. Let me just zoom you in a little bit. Now, this board I've found in among some of the spares what I've got, and I've not tested this one yet, so I thought I'd switch on the camera and yeah, we can have a look together. But this board, it looks like it's from a Lenovo, and the board number is an NM-E812. So straight off the bat, the things I've already noticed about this board is that it looks to have onboard RAM on here. I guess it's under this heat shield. Everything else seems to be complete. The processor's still got the heat pipe on here. I mean, does seem to have a bit of residue. It's obviously been used. We've got the slot here for NVMe, and it looks like there's a Wi-Fi card here, but there is no charging jack on this. We've got a HDMI and a USB on this side, and on that side we've got a headphone jack, another USB, and then the two USB-Cs. So I'm assuming it's just a USB-C charging only. So let's plug it into the USB-C and see what kind of current it's drawing. And two more things that I've noticed just before I do plug it in. In between these USB ports here, there's an LED. So I'm assuming that should light up. And also on the board, it looks like there's a switch here. So I'm assuming that might be a power on switch. And there was another switch that I found here. So there's one on the back side as well, another switch. So one of them might be the power on switch. Let's plug it in. So keep an eye on the USB meter in the corner, and I'll plug it into this port here. And oh, okay, so we're staying on 5 volts there. The LED has not lit, and we're not drawing really any current at all, so it's not negotiating. Let me try the other port. On there, it spikes up the current for a second and stays on 5 volts. So yeah, this is not happy. I'll just reverse the cable just in case. 5 volts, 5 volts. So yeah, there's no point in trying to power it on because this should be negotiating voltage. I'm assuming it should be like 19 or 20 volts. It's not doing anything, staying on 5 volts. So definitely got a problem on here. So let's dive into this, see if we can work out what it might be. Right, so let's go for a bit of a detailed inspection under the microscope. And I'm starting off here. These are the two USB-C ports on here. And the circuits look kind of similar. On there we've got a chip connected. It looks for each USB-C port, but neither of the ports are working, so I think we need to try and find RPD controller on this board and start from there perhaps. So also having a visual inspection, we might see maybe any signs of work that's been done. I mean, there's a bit dirty. I'm not sure if that's flux or not. Could be. Kind of looks slightly suspect, that. I don't know if that's a no connect there. Okay, we'll keep looking. So, oh, hang on, I've seen something. So we've got things going on here. This has definitely been worked before. We've got shifted components. Right, let me see if I can zoom in on here. We need to see what's going on there. Okay, so we're zoomed in now, we can get a better look. These capacitors, now they've obviously been worked on. They're in parallels, I'm assuming, so it doesn't matter that these are touching up here, but yeah, I'm not really sure what's going on. It's a bit messy. And this looks like a power management IC. There's a bit of stuff in there. Looks like a solder ball coming out the side as well. So I think we need to clean up this area. Up here, I can't really see what's going on. Might have to try and clean it up here, but that looks like a missing component there, and it's in line with this track, so that could be important. That might be some kind of pull-up resistor, or I don't know. We might need a schematic on this one, but I think they've used solder paste on here, because we've got, even on the side here, it looks like there's like little bits of solder balls around here, and these components have obviously shifted out of place as well. So yeah, let's keep looking, because I do want to find the PD controller. I'm not sure what this is here. This might be another power one. Now we know that there's been some work on here, it makes sense to do quite a good inspection. Here we go. So this is the RAM, and we're melted here. So I don't know if somebody was trying to take off this shield, maybe suspecting that the RAM was faulty, and applied some heat. Here we go. What's going on here? Again, yeah, this is flux here. Look, you can see that. But those are shifted. This one I'm most worried about here. Oh, well, you can see it's just come off with, it wasn't even soldered to anything. So let me take that away and save that one. Right, are these ones even soldered? They look kind of soldered, so we'll have to check that. I need to find out where that other capacitor came from. I'm assuming that's a battery jack. Yep. What else have we got then? So this area looks pretty clean. Can't see any work there. We've got a shield here with a coil. That's looking pretty untouched. Yeah, we definitely need to go through this, so let's check together. What's under this? I'm going to zoom a little bit out. Right, zoomed out, we can have a better look now. Oh, here we go. So what we got here, nothing much under there. That's the back side of the NVMe slot, but we've got our BIOS chips here. Looks like maybe this is our main BIOS, but that looks like factory solder to me, so I don't think anybody's tried anything BIOS wise on this board. There was that switch, so I'm not sure if that was the power switch. Looking clean around here. A Wi-Fi. Top of the board here. What's under here? I'm not seeing anything standing out to me. Is that display connector? I think we're good under there. And we're back to the USB ports again. So I'm not seeing my controller. Let's check on the other side of the board. Here we go. What's this? Yeah, so I think that this, on the other side of the board here, close to my USB-Cs, it's a TPS chip here. So I'm pretty sure that that's going to be my USB-C PD controller, charge circuit, etc. If it's a TPS, I'm assuming that's a Texas Instrument, yeah, TI3486 something, I think. So yeah. So to me, this TPS chip might be doing its job, because it will also be like handshaking with the other power supplies, looking for power good signals, looking for short circuits on MOSFETs, etc. And if it sees any issues with the board, it is going to cut our power to our USB-C ports on here, and it's not going to negotiate the voltage, but it'll be doing that on purpose because there is obviously issues on the board elsewhere. So I think we've got to go back to the problem area, and I think I'm going to start here first because before taking any measurements we need to try and clean this up. I mean, even there, these pins look bridged to me, so that's not right. Well, I don't think it is, but these are definitely on the side. So let's try see if I can clean this up with a bit of IPA first, make it, and then try and inspect it, I think. So I think I'm going to come with the hot air and probably remove this IC and then just inspect under it, because we've got this bulging out here and this one seems to be bridged. So let's inspect the pads underneath there, see if we can clean this up, and then maybe while we've still got some heat on it, so I don't know what that is, I need to remove that and see if we can straighten these out. Let's give it a go, see how we get on. We got pin 1 is down here. I'm assuming it's the right way. It does say 1 there, so does that refer to that part? Hopefully that's right. Right, let's get this heated up. I can see we've got flux coming out some of these areas already. That one's moving. So maybe that's got some lower melt solder on it. This IC isn't coming. Oh, here we go. It is coming off. Right, I'm going to put this one off to the side. The IC itself, that looks okay to me. None of the pins look damaged on there. It's just a little bit fluxy. But here I think we might have a bit too much solder, so let's try and clean that up, I think. But here I think we might have a little bit too much solder, so let me see if I can wick that away. So yeah, I think that's looking a bit more cleaner now. We can see here these pads that was bridging before. I'm not sure, this one looks like it might have been a no connect anyway, but I'm not sure if it was bridging with the third pad on there. But I think we are missing some components up here for sure, so I might have to dig out a schematic. I want to clean up these ones now and then we'll go there. So let me see if I can heat up these capacitors and sort something out there. Alright, the little ones come off, weigh that. Don't think we've got any component. Oh, we have got the small component there. Again, let's try and tidy up that area a little bit more with the wick. Good. So things are looking a little bit clearer there to me. Can start to see where things should go. Just want to clean up a little bit more here as well. Okay, so it's quite clear now to see these pads, but I'm not sure about what's going on here. Is that one shifted to the right and it should be sitting on a pad straight up? And these ones and this one. Let me try and reflow it and see what happens. This one really wants to move. Okay. I've got quite a low airspeed, so is it like that? Or should it be straight across? I can't really tell. And this one? Maybe like that. Crikey, it's so hard to tell. And is there something missing here? Don't know, guys, to be honest. We are winning. We have a schematic, and I've put it on the screen now. So you'll see here to the left, this is exactly the area what we're looking at here. So you've got PL, which is obviously this coil here. So this inductor coil PL401, we can see that on the screen there. And then over here, this power supply PU0401, we can see that in the schematic as well. And yeah, we've got this capacitor here, so that's fine. So looking at this, it looks like there should be a component across here, and across here, and we're missing all three of those. Looking at that, bearing in mind this board view, some of these areas might be like no stuff, but we've got these ones that we took off. So we've got these three capacitors there and the smaller capacitor to go back on. And the bottom side here, they do look like they all go straight up. So we've got a resistor there, and then I think we've got one missing, a resistor there that we need to put back on. We've got a resistor there, and then something here, and I'm not sure again if that should be occupied or not, or if that's like a factory soldered position. These ones here look okay to me. They look like they go across. Let me just double check that. Yes, so you can see they go like sideways on there, the ones that's selected, these ones. So that's correct. And then this one goes up and down. So I think we are missing this one here, which is probably important because from that trace it goes to that via. Without that component there, the signal is not going to go through there. So I think that one's important. These ones, again, I think that goes straight through. So this is probably just like a filtering some kind of capacitor across these two lines. So that'll probably work without that one. And again, this one, I'm guessing that's the same as well. And I'm not sure about this. I don't think that's a capacitor. But I've also got, as well as this board view here, I've got a schematic so we can look those up. In fact, I'll bring up the schematic now to see what it looks like. Alright, we got the schematic now. So yeah, we've got PU401 on the screen. And let's have a look here. Pin 1 voltage in, pin 15 looks like an enable signal. Coming down here, pin 14, and then pin 16 on modes. So I'm guessing there's like mode selects based on, you know, the resistor that's connected to those. We've got a 3v3, so maybe that's a 3-volt output. These look like grounds down here. Power good signal, but that looks like it's not connected anywhere. We've got an FB, so I'm assuming that's a feedback, so that'll probably be to measure the voltage on the outputs. And we've got a switched output here, so that looks like a switched 5-volt. And we've got CLM and BST. I'm not sure what they are. And a lot of these are marked BCAT. So I'm not sure what they are. I think these are like BOM code from the manufacturer, like where they may have made changes to the components on the schematic. Okay, so what do we actually need to know? We need to know what's these components here, especially this one, because I think that connects this trace going across here to these vias. So I might be able to get away with those two capacitors at the moment, but I'm sure this one's going to be required. So let's have a look what pin these two are here. I'm going to double check what pin it goes to. It goes here, and that's pin 3 on the schematic. So let's find pin 3. That might be an easier way. Pin 3, so that is the 3-volt 3. And there it is, PR0409. How to identify that component? I'm assuming it's a resistor because it's got an R. It says 0402, so I think that's the size. 5%, maybe that's the tolerance. Maybe 5.1 is the voltage. 1/16W. Let me just see if I can look up what that means on there. So I've managed to get a little bit of AI help just to identify that component. So the 116, that was a power rating. So we'll ignore that for a minute. I think the bit we need is the 5.1. That's not voltage, that's the resistance. So 5.1 is 5.1 ohms. So we need a 5.1 ohm resistor with a 5%. That was the tolerance, as I thought, and 0402 is the package size. So it's basically saying we need a 5.1 ohm resistor with a 5% tolerance in a 0402 surface mount package. Lovely. Let's see if I can get one of those. That's the next problem. I've just had a thought actually. That component that I found earlier, just hanging around, it's actually here, you probably can't see it. That did look like a resistor, so I'm just going to measure that. Maybe that is the missing component. So I've got my little tweezers on here, LCR tweezers, so I can put these into, they're in auto at the moment. Yeah, if I press R, it will change it to resistance mode. So let's try and measure it with them, bring in the microscope. Let's locate that component. Here it is. So I don't know. Is that a capacitor or is that a resistor? To me it looks black colour. Could be a capacitor, I'm not sure. So let me measure it with the tweezers. In fact, you're not going to be able to see it. I'll go overhead. Okay, I'm going to have the microscope here. I'll switch off the light. Right, hopefully you can see the tweezers here and I'll measure it. Right, so that's saying basically 12 ohms, 12.11 ohms. So it's not 5.1 ohms that we're looking for. Okay, I have looked out here. This is the only sample book that I've bought so far. I'm going to build these up to get them. But for some reason, the first one I bought was resistors of 0402. Exactly what we need. And I've already checked in this book. We do have a 5.1 ohm resistor with a plus and minus 1% accuracy. So we are winning. Let's get one of these out. Gonna need the microscope to see what I'm doing on this. Alright, we're spilling out resistors all over the shot here. Is that the resistor as well? Why is that a different colour? Okay, they're black on the top. So, yeah, we're losing them. Let's see if we can put some of these back. Only need one. I think I've just found the other one. Here we go. Right, can we put these back is the question. 1. 2. 3. Okay. Come in with the little pick. Get in. Get in. Okay. Not the right way round, but I'm not going to lose sleep on there. Let's go. Yeah, don't jump out. That's like kind of losing it sticky. Right, go back in again. Oh my goodness. It is so hard to work with this. Right, we're losing them more. Right. This is going to be painful to watch. I think we're going to need to cut this out. The slightest vibration and they all bounce everywhere. I can't do this. I thought I had steady hands as well. They're just pinging everywhere. Ping-tastic. Right, sit down. Okay. Carefully peel you back. Okay, that'll do. This is giving me an absolute headache. I can't even put them back. They're falling out the other side now. Like half of them are missing again. I think what I'm going to do is I'm going to tape that down to a bit of Captain tape there. And just trim it off to stop them falling out the other side. If you've got any techniques for these, I'd love to know. Right, hopefully that will work for me. Right, I finally managed to get that resistor situation underhand. So I've got my tweezers. I'm just going to measure the one out the packet to check what it is. Is it 5.1? Don't think you're going to be able to see. There we go. 5.08. So that's close enough. Looks like it's good. Let's try and get that on the board then. I'm going to try and tin up the pads now. So let's get a bit of solder on the iron. And a little bit of flux. Okay, let's just try and tin them up. That's where we want our resistor. We want these ones for our capacitor. Let's prepare for this IC again. I think we've got them all. Clean and inspect. So coming in now with our resistor, our 5.1 ohm resistor. Can we flip it around? Yes, we can. And that's going to sit there. So can we flow that into place with the hot air? Good question, and I don't know the answer. Let's go. We'll try. We'll just come with a gentle heat. Let's see if that solder will melt. I'm not going to touch it. I'm going to give myself a little bit more height. I didn't have the angled nozzle on, so I've just given myself a little bit more height. Very gentle nudge. Now, is that going to go into place or not? I think that's good. I can feel the solder look like it's sitting down. Why have I got flux all the way over here? Maybe this has been reworked over here. I'm going to clean that up. I'm just not liking the looks of it over there with those diodes. Looks a bit fluxy. I don't know if that was me blowing the flux over. Okay, so are we on? Yes, a miracle. That resistor's on. I'm going to try and put those capacitors back. I've just added a little bit more flux. So here are the two big ones. And the third big one. I don't know how, should I try and separate them first? Let me try and separate them. I've managed to separate them and clean them up a little bit. So I'm going to try and get them in position, and then we'll just try and flow with them in. Okay, that one's good. That one looks okay. That one. And get them to separate. I think that's the best we'll do until the solder's liquefied. Okay, come in with the hot air. We'll just take this steady. In no rush. We've got another pad under there for that small one, so hopefully that will reveal itself when they sit down. We're bubbling over here. It's strange because I don't think that's my flux going over there, so maybe something was worked over that part. This coil is moving. Alright, I think we're liquid. just, yeah. I think we're good, I think we're good. That small one. No. Right, I got this tiny fella. Will that one go in? Probably going to lose this one, but we'll give it a go. Come on. I think that might be alright. Oh, I don't want to touch it. Make it worse. I think we're good. I think we're good. Right, has that gone solid? No. That's gone solid now. Right, that looks soldered. And these two, yeah, they're all okay. I think we're all soldered on. I'm not going to clean up yet. I'm going to put this IC back on, I think, and then we can clean up. This way. Like that. I'll get it roughly in position. Hopefully we'll see that move in place. Right, hot air. Come on. I think this is the last one. Oh. Yeah, so I think the flux is making it float. I don't think the solder liquefied yet, so we might be alright. Not sure. It's burning my hand. Go try and go from this angle. I know I'm nudging that. Sort that capacitor out in a second. It's hanging on this corner. Oh, did that jump in place? Try and get this back without touching that cap at the side. Not sure. It doesn't want to move now. Not sure if I've got it. Try a tiny nudge. Oh. Caps. Oh no, no. Okay, let me put some pressure, take the heat away. I'm going to have to clean up and see how we are now. Okay, so this is what we're left with. How does that look? I know those capacitors have just gone slightly off, but I think they're still connected to the pad, so that's probably the least of our problems. This resistor still on okay. It's just a case of did that solder on properly or not. Try and come from an angle. I mean, all those pins look connected to me. Let me try the other way. I think we've got that, to be honest with you. Maybe that fourth pin along, but it's connected with the other two anyway. Obviously I can't see under the chip, but it looks to be pretty much central aligned. So I think that's okay. Where was the other damage on the board? Yeah, we got things going on over here. But to be fair, everything seems to be soldered okay. I know there was that component that we found. I think that measured 12 ohms, didn't it? So where did that go? I'm not sure if it was a resistor or a cap. I'll tell you what, let's do another test on this board now, see if that's made any difference at all. Okay, so USB meter's still running in the corner. Let's see if we get anything other than the 5 volts now we plug it in. I don't expect to, but yeah, 5 volts on there. And yeah, still the same, 5 volts on there. So I think at this point then we are ready to start maybe taking some measurements, because we've still got the same. We've dealt with the obvious damage and issues that we've seen. So it probably doesn't resolve the original problem why they started working on the board. So let's get under the microscope with the multimeter probes and let's do some investigation, I think. So it makes sense, first of all, let's take some measurements around where we've been working here, because they're obviously working here for a reason, so maybe this is where the short was, if we're lucky. So I'll put my black probe on ground, and let's measure on this coil. So that looks like infinite resistance on there. What about on this capacitor here? So that side's ground, that side is fine. What about these ones up here? So that's that side ground. No. Hang on a minute then. So we have got a short. That's like 0 ohms there. So that one must be ground. But this side here, I've got 5 ohms. And I mean, unless that goes to the CPU. No, I don't think it was when we looked at the schematic for this chip. I don't think that was a PSU for the, well, it's not even there, the CPU. The CPU is going to be up here somewhere. So we're down here, kind of closer to the RAM. Yeah, down here. So yeah, we've got a short there on this side, yeah. No, that one side's ground. This side here, 5 ohms. So what about on this capacitor? 5 ohms, yeah, and then this side is 0 ohms, yeah. So I think at this point we've already found a short. Let's inject into the short here and stick a volt in there and see if it's drawing any current. Okay, so I'm getting ready to inject some current, some power. So the way I do that is I connect this to the black lead here that I made and connect that to the USB. That will give me a nice solid ground to inject into, and then with this probe we've got this with quite a decent chunky multimeter probe in there, so we should be able to get a nice contact into the board. Let me get the thermal camera ready and then we can monitor it as well. I'll see if I can bring the thermal camera on the screen at the same time. Okay, so I've got the thermal cam up here now, so hopefully we can see that on the screen at the same time. Now obviously looking in the thermal cam you can see places like this Wi-Fi here, this shield, anything metal kind of reflecting, so that's not a heat spot like these screw holes and the ports, they're just reflecting, but we should be able to see if something heats up on there. So let me turn my power supply on. I've set my voltage at 1 volt, so you can see that, and we can monitor the power supply in the top corner. Let me just make sure it's working. I've just tapped on another ground here just to test it through, and we're drawing a couple of amps, so yeah, it's working. So now let me get onto the spot on here that was shorted on these capacitors. I'm on them now. And we're drawing 350 milliamps, so let's see if anything's getting hot. Hang on, looks like something's getting hot up there. And if I let go, I can see it disperse. Did you see that? Between these two screw holes, something up there. I'll just go again. See that? So we'll come in with the macro lens now. This is the beauty of the P2 Pro. We can get up close to that area. So it was something up here. So let's keep an eye on that as I inject again. Here. Let me come off the power. See that go down? And back onto the power again. Yeah. So that's glowing in one corner of that chip there. I'm just wondering if that coil's getting hot now. That's just a reflection from the light above. But that chip there, if I come off it, you can see it's definitely getting hot. That's easy to spot. And off the power, there you go. So what is that chip there? That's my question now. So it's this one here. I know where it is on the board. Let me take you over to the microscope. Okay, so here is the chip here that was getting hot, which was getting hot in that corner there. I'm not exactly sure what that is. It might be a MOSFET driver, integrated like MOSFET driver, I'm thinking. But this is not good. It's not good because if I look down here, we have a CPU under there. So I think that these may be power stages for the CPU. This one is like a no stuff on there from factory, but it looks like an exact replica of what this would be here with the coil, this capacitor and this other chip here. So this is maybe a power stage, and then this one isn't actually required, maybe because, you know, if it's an i9 version it might need two, and then maybe this one's slightly different, so maybe that's like a boost or something. Is that the same? It does actually look the same, this one on here, as this. So maybe you've got, you know, two phases. But yeah, that's heating up. So maybe the CPU is shorted. Let's have a look then and take some more measurements around here. Okay, so coming with the measurements here, just to take the resistance. Let's try on this coil then. So yeah, we got about 4. So I'm not sure if that's the same as what it was. I thought it was closer to 5. So if this was shorted through, this MOSFET, we'd expect to see whatever that was here. So yeah, it is like about 4 or 5 ohms. So coming in the other side of this MOSFET, let's check these. 5 ohms, 0 ohms, yeah. So on this side, yeah, we're shorted through this MOSFET. That's what I think. I think this is faulty. We're shorted through here, so we're obviously seeing the CPU. And we shouldn't be seeing it up here. We should see the CPU resistance of like 5 ohms on this coil, but I don't think it should be going through this MOSFET. And there's the resistor here as well. We're seeing the 5 ohms everywhere, and I think we should have high resistance on this side. That's what I think anyway. Now, I'm going to struggle at this point because I definitely don't have one of these ICs. But let's look that up on the schematic and see if it is what I think, a MOSFET driver. We might be able to get a data sheet for that actually. Okay, so I think I figured this out. So we've got PU1101, this one that's shorted on here, and I have checked what that is, and I'm just going to show you on the camera now. So we can see here on the board view, PU1101 is here, and it goes obviously to this coil, and this coil comes out as VCCGT on there, which is, as I expected, as you can see, all going down here, powering the CPU. So it's definitely a CPU power phase. Now, if I switch over to the schematic as well, yeah, we can see on the schematic here, PU1101 as well. And this is like a MOSFET driver, like a monolithic driver. And I've got here, the part number is an NM-E812. And we can see some basics on here. We've got voltage in, 2 voltage in inputs on here. And if I look at that voltage input, it does say it's VSys 15. So this must be a main power rail, the VSys, and it must be like a 15 volt power rail on this laptop. So that's the voltage in, and then out of there we get this VCC on there, which is the output, and then PWM, VCC, GT. So yeah, that's pretty straightforward. Oh, here we go. Actually, yeah, this is the main output on the switch. Switch 1, switch 2, switch 3. These 3 switched outputs on here, they create this power rail, which is called VCCGT on there, and then it's going through that coil PL1101. So I think that's pretty clear cut. Now, what I have done is also found the data sheet for this. Let me share that with you. Yeah, here we go. So I've got the data sheet now, and as we can see on here, this NM-E812, it's a monolithic half bridge with an internal power MOSFET and gate drivers. So it's exactly what I said. It's a MOSFET and a driver as well, all in one package. But I have heard good things about these monolithic drivers, that hopefully, if it's gone shorted, it may have protected. If the high side MOSFET in there was shorted, it could have protected the CPU. Got a typical application in here, which is as we've seen on the schematic, where we've got the voltage in, the system voltage, and then we've got the switched output on here through this inductor coil, etc. So yeah, I think it's worth ordering up some of these and trying to replace it. Currently I don't have any spares, otherwise I'd do it in this video, because I'm really interested to see if that will help or not. But as of now, I think I've taken this as far as I can take it, unfortunately. I'm definitely going to order those monolithic drivers and do a follow-up on this video. But it seems to me at the moment, all the laptops I'm doing need following up. I've not got the parts, and I'm really struggling because I don't actually have any donors yet as such. So we need to try and write off some boards as well that are not good. We use them as donors, use them as parts. So I'm going to get the monolithic driver. I'm going to stop this video here, and I will be back on a part 2 trying to fix this board again. But I hope you enjoyed it and these steps. If you have got any more advice, there may be other faults on this board as well, but we can only deal with the faults one by one as we come across them. And at the moment, I think we've got to do that one and then go from there. So yeah, I hope you enjoyed this video. Thanks for sticking around if you're here. We'll just give a quick mention to my supporters on the channel, the JFix followers. I really appreciate you, and also the JFix legends, who I'm going to put on the screen now, for your additional support. I really appreciate it as well. So thank you. So yeah, thank you, and I will see you in the next video.